Hi, everybody. This is the API Machinery Sig Deep Dive. I'm Daniel Smith. This is David Eads. We've got, let's see. Yeah, this is our agenda. First up, I'm going to have my colleague Jenny talk about apply, since she's been working on that. Then we'll go to control plane fairness. I'll say something. And then David's going to talk about certs. And then that's probably enough, so we'll probably take questions there and save the CRDs in case everybody is like really ready for more stuff. So, okay, with that, here, Jenny.
Thank you. I'm just going to talk really briefly about server-side apply because it's in alpha right now and we're going to be moving it to beta soon. Next. So yeah, server-side apply, if you don't know, is we're moving the logic from kube control apply into the server, so it won't use strategic merge patch anymore. And most of that is pretty straightforward. If you send a resource to the endpoint, it's going to do the same thing as if you had run the client-side apply on it. But there's a few differences, and I'm just going to talk about those for a little bit. This is all the stuff that's the same. It accepts a partially specified object, and it knows the structure of the resource from OpenAPI. But we actually built a different schema format for server-side apply, so it won't be tied to OpenAPI v2 or anything. And that's all housed in a separate repo. So for client-side apply, the way one thing apply needs is a sort of history of the requests that have been made in the past. And for client-side apply, the way we did this was with an annotation that would store the entire copy of the applied object. And this worked for that because it only has a single user, but when we wanted to move this to the server, we know we needed to support multiple users applying. And if we just scaled this by copying it for each user, it wouldn't work because the size of the object's going to go up linearly. So instead, we need to put something in there per user that is the size of 1 over the number of users. So we had to find something that would fit that requirement. So this is if we just copied it, yeah, once for every user. So in order to make it smaller, we removed, so we have, each field will only show up once in the sum of all of these last applied configuration things. And once we split it out like that, we realized we could actually remove the values too, because the information that was necessary to decide whether you had the current version of that field could be gathered from whether or not your set of fields contained the fields you were updating. So we have this concept of a field set, and this is all built in a repo structured merge diff under Sig's k8s.io. So we have some basic methods that convert an object into field sets or multiple objects into field sets, and then some other things that operate on field sets themselves. And you could see how these operations could be combined into some apply behavior pretty easily, but there's one more thing that's different between client-side apply and server-side apply that's pretty complicated, and it's multiple versions. So when you convert between versions, what actually happens? One thing that could happen is the field name can change, and this is an example of that, just changing the field name, changing the value. That would be pretty easy to handle, but it's not that simple. We could also have a field turn into multiple fields, or the other way around. Or you could have 2 fields turn into 3 fields and then turn back into 2 fields, but in like a little bit of a different way. So these 2 fields actually, yeah, they get all mixed up. It's end to end. But it's even worse because you could also have a field value become a list item, which is like, can be, or a map key. So this is like a pretty common thing in the Kubernetes APIs when you forgot that you needed a list, and then the next version you just add additional letters to the old version. So since conversion is a black box for apply, what we do is we have a convert function that's exposed to the apply repo. And all it knows is that it can convert full objects. You can't convert the field sets, and you can't convert those partially specified objects. And you have to be in the same version for 2 field sets. So it gets really complicated to do the logic for apply now, but luckily it's in a different repo, so we could test it really well, and it's decoupled from Kubernetes. That's all I was going to talk about.
Cool. Thanks, Jenny. All right, that's awesome. We'll take some questions afterwards. But right now, I wanted to talk about flow control, which is basically the problem is if you make a bunch of requests of API server, it will fall over, and that's not good. So we want to fix that because, like, right now you basically can't you can't drive to the edge of what your API server is possible because there's no fence and you'll just fall over. So we want to put up a fence so that you can increase your utilization, like provision your master or your control plane nodes, provision those better. Yeah. So we have a few goals with this effort. Prioritization. Some requests are more important than others, and we want to make sure that those get more of the throughput. 2 examples are system requests might be more important than user requests, but even within system requests, some requests are more important than others. Like leader election is more important than adding a random event, right? Fairness, that's the other major property is like within a priority band, if 2 people or 2 agents are sending requests, we want them to get honored about the same. So, and then I'd say like our other goals are like, let's protect the CPU, let's protect RAM, at least while actively processing a request. There is a, oh yeah, got this guy. Yeah, so in order to get something out in a reasonable amount of time, we took on some non-goals. This is not a solution for hostile DOS prevention because it doesn't like it doesn't protect the SSL handshaking or like the queue itself. So we're not quite all the way there to solving that problem, but hopefully you don't have your hopefully you don't have that problem yet. Eventually, eventually we will. So we're not protecting like the RAM from queuing the request. We're not protecting CPU from SSL handshaking because you got to answer the SSL handshake whether or not you're going to answer the request. You don't know at that point. So maybe in the future, but not for the first take. We're also not addressing the load balancing problem. Like you could make requests of you've got 3 API servers running. To get all your throughput, you're going to have to talk to all 3 of them. Sorry, maybe next take we'll add a balancing layer or something. And a future goal, I think an important future goal is to make it automatically tune itself. So it is monitoring how much CPU am I using, increase the concurrency. Yeah. How does it work? So this is sort of the design that we've sketched out. And this has been, the people working on this have been Min, who's sitting right there, and David Eads, and myself, and Michael Spreitzer, and a few other people, but that's been the most of the participants in the conversation. Oh yeah, and my teammate Aaron. So we're adding 2 API objects, a flow schema and a priority level configuration. And basically so a flow schema is going to describe how to map a request into a queue, and a priority level configuration is going to list how important the queues are. So this graph here is kind of illustrating how this works. So let's start up at the let's see, where's my, oops, I'm pushing the wrong button. Nope, there we go. Yeah, here we go. So up at the top there's a request, all right? And well, let me back up. The basic idea here is shuffle sharding. So we're going to make a number of queues, and the idea is we're going to hash the request in some way. That we select a few queues. We take the shortest one and put the request there, and then separately we dequeue. That's the overall scheme. Let's zoom in just a little bit. So we have a request. We compute some sort of distinguisher. the distinguisher is part of the flow schema. It's the way of computing it. We use the distinguisher to hash. So the distinguisher is going to be like the namespace or the user, and we might add some more in the future. But you're gonna take this, hash it, and that lets you decide how some number of queues. The level configuration gives you a hand size and a total number of queues, right? So you might have like 128 queues, and you're going to pick a hand size of like eight cards. So the shuffle sharding step gives you 8 choices of queues, and then you pick the one that's the shortest. So what this does is, if you've got someone or some agent who's sending requests, let's say it's by namespace, and it's this one namespace is sending you gobs and gobs of requests. This will confine them to just 8 queues. And like they'll fill up those queues completely, but that leaves so many other queues. And if you do the math, it's like really good, like the percentage of queues that will be free, and the chance of those 8 queues completely overlapping with an agent that's just trying to send a few requests is very low. So yeah, I'm really excited about this. This was my contribution to the design. Yeah, so that's great. And then let's talk about the dequeuing step, which I think I have one more slide. Yeah. So the dequeuing step here is like each priority level has its own set of queues, right? And so they're more or less full. The dequeuing step is using a thing called fair queuing. Michael Spreitzer helped us adapt this. And so it's basically going to go in a loop, and this is where the prioritization comes in, because the priority level has a number of shares. So if one has like 30 shares and the other one has like 10 shares, then you get a certain percentage of the overall throughput. And then the dequeuing just basically goes in a circle while it's got the capacity to handle another request, like pull it out and service it. I'm not sure if we're going to make alpha for this release, but soon, hopefully. We're still sketching out the, Vin's like, we're still sketching out the API. We're close. But I'm excited that we're going to arrive at a pretty great design here. So with that, I'm going to turn it over to David, and we're going to hear about certs.
Thank you. Everybody loves a cert. So before I get started, quick show of hands. Who listened to the Kube API server without hookups talk? All right, I've got 2. A few more. All right, so certificate settings today. We do know that we have a lot of them. If you start trying to collect them all, you end up with a chart like this that doesn't quite fit even at the smallest possible font size. And you may think these are some mad scientists, and he is. But the rest of us are trying to figure out how to handle mTLS connections between multiple sources. So when you actually break it down, it's not as bad as it initially seems, right? It's a few specific kinds of connections. So I've gone ahead and listed them here, and I'm going to go ahead and get into some detail. So you have etcd, and you need to be able to have the Kube API server know that it's speaking to the correct etcd, and you have to have etcd be sure that it's the Kube API server trying to write and not just some other agent. That actually takes several flags to do, right? You have the same kind of connection with the Kube API server when you're trying to serve. Quick show of hands, cluster admins, people who actually try to configure this. Right, so you guys are familiar probably then with setting up SNI. You know that you have to set several flags to pass us that cert that you bought. And you have to set several others that you may not care about. But then you have client certificates, right? And this is a way for the Kube API server to terminate the connections and identify users from them. And the 2 most important ones that you see are for end user connections, where if you have a PKI infrastructure, you're signing certificates for users, and you want them to be able to use their certain key to talk. And the other one that is really common is kubelets, right? Kubelets should use a short-lived certificate that uniquely identifies which particular kubelet is speaking, and you have to be able to terminate both. The next one is a front proxy certificate. So there are actually two uses for this. One is to set up your own front proxy. Actually, of the cluster admins, how many of you guys actually do set up an authenticating front proxy in your clusters? Okay. Then the other use of it, since you guys don't do that, is for aggregation, right? So you're familiar with the metrics server. It's probably the most commonly used one. You have to be able to authenticate users, and the way it works is a request comes into the KubeAPI server and is forwarded with identity, and you again have to have that mutual TLS connection. Kubelet serving has to be trusted by the KubeAPI server. Kubelet clients have to be trusted. And the kubelet has to be able to terminate connections from the KubeAPI server. That one's a little less obvious. People don't always know that one. The last two are also related to, are also flags for the controller manager. So we have the service account cert that is used to sign a JOT. So it's a signed token, the details of which you may or may not be aware of. But it's yet another interrelated cert that you have. And then finally, the CSR endpoint. So does everyone already know how the mTLS connections work? I see a couple, but I will go ahead and briefly cover it. So what happens is that you have a client who needs to be able to identify itself to a server. And so it has a certain key, and the key is secret. And it identifies itself to the server who terminates using this client CA bundle, right? So we're up to 3 flags already. And then your server is going to have 2 sets of certs for identifying itself back to the client. It's going to have a default cert, and it's going to have SNI certs so that you can specify different names and get the correct certificate served with it. And then the client uses the server CA bundle to trust on the other side. So you can see here we have, what, 1, 2, 3, 4, 5, 6 flags. You have enough of these connections, and they do start to add up. So a few of you are probably sitting here thinking, I have my own PKI infrastructure. I verify all the certs before I sign them. I want to use what I have. I have a single root CA that I'm going to use for all this. And why do you have all of these different chains? And the answer is that you do, but for every one of you, there is somebody else who doesn't. And they just want their connections to work, right? And they want them to be secure, and they don't want to worry about it. And so having distinct chains of trust, it's not a perfect way, but it limits the blast radius should something go wrong. So I'm going to give a few examples, and I've labeled all these pictures, so if anyone's looking later, they can actually see all the different flag names related to the connections they have. So you can see you have kube control talking to the KubeAPI server, and those flags on the KubeAPI server are the actual ones you set for this purpose. So I'm not going to go through all of them because you can read them. But you have kube control to the KubeAPI server, KubeAPI server to etcd, a duplicate, the kubelet to the KubeAPI server. So this is when the kubelet is asking for pods and services, volumes, PVs. It asks for a bunch of stuff. Then you also have the KubeAPI server back to the kubelet. This is the one that happens when you're trying to do a kube control logs, right? That's actually a proxied call. So you're making a call to the KubeAPI server. KubeAPI server then makes a different request on your behalf to the kubelet because you don't necessarily have network connectivity and your cert isn't good to terminate there. And it has to be able to verify it's talking to a real kubelet. Now we have a slightly different case. It's not just a straight request to the KubeAPI server of a certificate. That one will normally terminate and give a user identity on the request that is related to the cert that you used. There's another case where you have a front proxy set up, and this is what I was talking about with aggregation. So you have a front proxy which terminates TLS, and it decides which user you should be, and makes another request, proxied through, that asserts the identity on that request. So if Deads2K makes a request to the server, he would make a request to the kube aggregator, which is built into the kube API server, for metrics. The kube API server says, yep, I recognize this. Somehow, this is Deads2K, and I'm going to assert it to the metrics server. And so the metrics server has to confirm not that it's Deads2K, because Deads2K didn't make the request. Right? The one that it sees is actually from the kube API server. It needs to see, is it really the kube API server talking to me? Does the kube API server have the power to assert identity? OK, yes, it does. And it is Deads2K speaking to me. So there's two common ways you'll see this in clusters. Someone, apparently not uncommonly, will use Apache with, say, mod auth. And they will have Apache terminate the connection. Apache will decide which user it is, and then send it on to the kube API server asserting identity. And then the other case, which is common if you're going to be using metrics, is to have the kube aggregator send it through. And there are a few other aggregated API service catalogs as an example. OpenShift has an aggregated API server as well. All right, so certs, CSRs, and kubelets. It's important to always remember the relationships that you have between the components. And this can be kind of difficult, as in this example. We have a set of 3 binaries, total of 6 flags, and they are all related. They have to move together. If you're going to turn on kubelet rotation, you need to be sure that your kube controller manager is actually going to sign those certificates. So you have to pass the flags for the kube controller manager, or you get kubelets that don't go anywhere. They get stuck waiting for their cert to be signed. And then even after you've done that, you need to make sure that your kube API server has the CSR cert that you use to sign from the controller manager in its client CA bundle and inside of the kubelet certificate authority. I had to look, I don't remember that flag. The kubelet certificate authority. And if you forget any of those pieces, if you forget the kube API server pieces, you can have kubelets that can't get a list of their pods that run on them. They'll get 401s back. Or if you forget the kubelet certificate authority, you'll get a kubelet that you can't get logs from. I guess I can admit that I have hit that before, and it is quite frustrating to debug. And yeah, we will actually pause here for questions, if you have them.
Yeah, thanks, David. Any questions on anything? It doesn't have to be limited to this.
There you go. No. So the question was, is this thing that I've discussed here, the situation where you have 6 flags that are all interrelated that span multiple binaries, is this the objective of the component config to solve? And the answer is no. The component config is trying to solve the problem of how do I represent the configuration for an individual binary, but it's not going to be opinionated about how that configuration is distributed. Not all distributions or configurations are going to agree on exactly how that's set. So the component config is the common denominator.
I'd even go so far as to say in the short term, it'll probably make it worse because you'll have like files and flags that both work at the same time.
It will make it a little bit more difficult. You'll have a priority to remember. I do think it's going to be worth it in the transition, though.
Yeah. And an additional complication to think about is like if you've got 3 API servers in your setup, that's 3 possible places for this flag to be wrong. So
it is, and component config may help with that eventually.
Yeah, although,
The path from here to there is going to be fairly long.
It'll help with that because we'll have to figure it out to make it work for API server at all.
Probably. Any other questions about any piece of API machinery? All right. Nothing?
Well, want to tell us about CRDs?
We can talk about CRDs. Just before I do, though, this is similar to Stefan's, the end of Stefan's talk about OpenAPI publishing. What percentage of you guys were here for that? A fair percentage. I'll buzz through it real quick. So there are a few pieces that are going to be important for CRDs to go to GA. We want the behavioral changes related to CRDs to all land before we make it GA and be on by default. That doesn't necessarily mean GA themselves. Some of them will probably still be beta, but on by default for behavioral changes. And so on this slide, those behavioral changes are OpenAPI publishing, pruning, and defaulting. Those are the ones that I can think of right off the top of my head. So pruning seems a little weird when you first see it. If you have a non-existent field and you submit it to any normal API resource, it will actually be removed on its path to etcd. It gets removed because I think very originally that was just what Golang did, and Daniel let it happen.
Yeah, that was,
Yep.
yeah.
And so it has a couple side effects, one good and one maybe not as good. So we'll go not as good first, veggies first. What happens is if you're trying to do a create of a cool new feature and you happen to use this manifest against an older server, we've probably all done this, it gets created without your feature. It's really, really frustrating. Client-side validation helps with that. And when you can use it, it helps when you have a client that doesn't use client-side validation, like they don't all use it, you can end up annoyed. Then there's the good half of this, field squatting. So if you have some special new field, maybe it didn't exist in release, I don't know, 1.3, but you added init containers. And you had someone who was smart enough to create an init container piece inside of their pod before you upgraded the cluster. You upgrade the cluster, and suddenly there's an init container that gets created that shouldn't be. It's a super privileged somehow init container, and it owns your cluster. You would be very unhappy. This is the good part about pruning, right? It prevents this from happening. But as Daniel admitted, he wasn't smart enough to predict it. It just happened.
Yeah. This is totally like we just used the standard Go JSON on Marshaller, and that's just the way it worked. And like if we were doing this again, I would reject fields that aren't understand instead of silently dropping them.
Maybe give an option to reject or ignore.
Yeah, I don't
To the
know.
caller?
It's not really a live question, right? But
Yeah, it doesn't matter so much. But the other thing that is going to be a behavioral change is defaulting. So we're all familiar with the easy case of defaulting. You create an object, you want a default value, you write to the server, it gets written to etcd with a defaulted value, you do the read and it comes back out. This is the case that people see and they all think, well, I can just do defaulting in my own mutating admission webhook, right? And for this case, you are correct. If you have absolutely no data, you can do this. But if you later decide to add a field, then you cannot do it with a mutating admission webhook because defaulting happens on reads. The example that we have here is of a stored pod. It came in a previous version. It does not have this neat defaulted field, right? But when we upgrade and we have defaulting, when we do the read, we will get that fancy new defaulted field on the read. We don't have to rewrite the resource. etcd still has it empty, and it happens on the read side. There's no admission on reads, so you can't reproduce this functionality. Arbitrary subresources is something that I'd like to see on the roadmap, and I do not believe it is required for GA, though. And the reason I don't think it's required for GA is that it's not going to change the behavior of existing functionality, right? If you look at pruning, it changes what's actually stored. If you look at defaulting, it changes what you actually read. But this is just an additive change that allows you to have more power, right? And the idea here is that you could do something like logs or port forwarding, right? If you know how a logs request work, and I sort of mentioned it, you go through a QAPI server which has a bunch of logic to decide, can I proxy, where do I proxy to, then I use my identity to proxy it.
using some of the flags that you just talked about.
Yes, anyway, does all those things. We can't realistically build this in to the QAPI server, that logic. We can't We can't allow someone to write that program and have us run it for them. But maybe something like API aggregation. We haven't thought about exactly how we would do it, but I think we both agree that it's a functionality we'd like to have.
Yeah, it'd be super awesome. I'd actually like to take all of that functionality and get it out of API server.
Yeah, I think that would be good too.
Yeah.
And then the last one that I came up with was priority. If you've worked a lot with CRDs, you may have hit this. Some names are just popular. Policy. It's not policy. No matter what it is, it's not policy. Because what happens is somebody else will have policy. You will try to get a policy, and you won't get the one you want. So the example I have here is a foo, and it's in 2 different groups. And you do a kube control get foo, and which foo should you get? Right now, the result is predictable, like it's the same, but for the life of me, I can't remember what it is. And I think we need to come up with a way for people to weight and balance them. Part of the problem is that everyone will believe that theirs is the most important. I mean, clearly you want my policy, not Daniel's policy. So like the one consistent rule that absolutely everyone agrees to, no CRD should ever get to override a core Kubernetes resource. So we're not going to allow that to be possible. But I think we'll be trying to add functionality for this at some point. Still, I would say in your scripts, the standard advice is always there. Always specify your entire resource version group when you specify it, so that you get consistent serialization as you try to do something like output to JSON.
Yeah, that's super important. At one point, we had talked about making kube control detect whether a terminal was attached and like reject short names if.
That was like 2015 with Brian, right?
Yeah, it was a while ago.
It's not likely to happen.
Yeah, but use full names in your scripts.
Yeah. All right. Did that kick loose any questions from anybody else? Yeah.
So for those of us who are, for example, we have need for sub-resources that aren't supported in custom resource definitions. We've been trying to make use of the QBuilder Alpha project. What's the roadmap or the future with the API Builder project?
API Builder project. One of Phil's?
Yeah, Builder Alpha, I think they call it. It's an incubator.
We can both be embarrassed to say, I don't actually.
I don't know if I know
that
that one, but it looked like Min did.
Do you just mean the API Server Builder Alpha? It's a builder SDK project for API Server aggregation, right? Oh, yeah. I'm running that. It's almost, yeah. It's exhausted. For now, we didn't have a better SDK builder for the API Server Builder, for API aggregation. But yeah, we are still putting some manpower into maintaining it. So what's your problem with it? Yes. Oh, yeah.
I suspect that, so there was the overall conversation, just for the record, was about, I think, what project would we use to try to create something to serve CRD sub-resources or a similar API server. I suspect that once we actually create the ability to serve CRD sub-resources, there will be more interest in creating compatible servers. To that end, we actually created the K8s.io API server repo with primitives that would make this possible. It's not necessarily easy today, but I think that once the CRD feature comes, we're going to see more.
So speaking of sub-resources, there's 2 categories of sub-resources. There's things like the scale sub-resource, which is like I took some fields and I manipulated them in some way, and now I've got this this type that I can serve from multiple places and multiple people can understand it. The other kind of sub-resource is like logs, as exec, attach, port forward, where it's like some completely non-Kubernetes specific or Kubernetes specific and strange protocol, which is not like a declarative thing. So those two cases are quite different. Yeah.
They are different. There's a third one. It's a controlled escalation. If you look at, say, pod bind.
I group that in with the scale sub-resource. That you can permission them differently, right?
You can permission it differently, but since you can do anything inside of it.
Yeah, I think the namespace finalizers are the same.
Yeah.
Yeah.
There's a few examples.
Certainly the logs, attach, port forward, that sort of stuff, I think that needs to be implemented in the front door and like the aggregator if we want to customize that. So it'd be like you're registering for it in the API service object. We haven't actually designed this yet.
Yeah.
Yeah.
Extra verbs, I don't know that I see us doing.
Well, I think the statement is that things like this are effectively extra verbs.
Oh, okay, sure.
Yeah, I would actually discourage the heavy use of things like this. I would often encourage you to model the process as a object, just like we have a CSR resource type, like a certificate signing request. Like you might think that request is a verb, but actually we made a noun to track the whole process. Because I think a lot of requests are actually not simple requests, and there's various things that can go wrong. And even if you think of it as a single flow, you may actually want multiple actors to get involved. Again, to use CSR as an example, there's a signer and an approver, and these are separate, and maybe a human stands in to approve some things. So I'd encourage you to think hard about maybe there's another way to represent it.
All right, I think we should probably call it here.
Yeah. Okay. Oh. Do we have time for
Sure.
one more? Yeah. Okay. One more. Last question.
I actually want to ask about the server-side applied. Is the server-side planning to work with customized resources?
I don't have to take it off.
Yes.
All right, we're done.
Yeah, we're going to make it work with custom resources
That's
too.
good.
Yeah, that's important. Yeah. Okay. Thank you, everybody.